Okay, hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company provide technological solutions across the world. Now in this session we are going to predict the supplier performance with the help of deep neural network, right? Now first let me explain you exactly what we are going to do. For example, let me show you with an example. Suppose I have two suppliers, no, not two suppliers, for example two friends, friend 1 and friend 2, right? Now friend 1, what he does, whenever I call him he comes immediately, right? Whenever I call him he comes immediately, but whenever I ask for some money he never help me, but he comes immediately, right, whenever I call him. So this is also my important friend. Secondly, this is my another friend, he never comes immediately, right, but whenever I ask for financial help he immediately helps me. So both are my friends, are important, but they are on the basis of different criteria, right? This is just an example on the basis of different criteria. Now let's come to the point. Here also supplier, a company is having different suppliers, right? A company is having different suppliers. Some suppliers provide immediate goods, immediate material. If the supplier is suppose you are having 10 suppliers for the same item, so 10 suppliers, out of which one supplier is always famous for delivering immediate material. Second supplier is also good, but he supplies, he does not supply immediately, but after some time, but he supplies good quality material, right? So these are some different criteria on the basis of which we decide that which supplier performance is good when there is a urgent requirement of material, right? This is something like performance of the supplier, right? Performance of the supplier, that on the if the condition comes, like urgent situation comes, then what would be the we can say the performance of that particular supplier. As I given you the example of friends, I have two friends, both are different. One comes immediately and the other he never comes immediately, but whenever he is asked for financial help he definitely helps. So both our friends are important. Now it depends which friend you will need, that depends on the criteria, right? Same thing here, performance of the supplier. Now suppose I have downloaded the data of supplier from NetSuite ERP, okay? Now here our main target is to discuss how deep neural network, ANN, CNN, everything helps and supports business. That's it. Now see here, just a second, here it is, okay? Now if you see here, on time delivery rate, that is what I was giving you the example of two friends, right? On time delivery rate, we are having so many suppliers, and on the basis of which we have created this 81% on time delivery. See here, some suppliers they provide on time delivery rate is 75%, right? Then quality score we have given, he is providing on time delivery, but his quality score is less than this person. Then you will see here cost efficiency is another factor, right? Then you will see here the compliance score. Compliance means whichever related to like RERA, and if you talk about builders point of view, right, constructions point of view, there is one more institution, that is RERA compliance. Then we see here the flexibility, how immediately, how flexible he is to provide the material, and then performance score. Right, now here is a performance score. Look at this performance score that we have to derive. This is our dependent variable and remaining all the independent variable. Okay, so let's start with this. Now let me show you the PPT also first. Right, here NetSuite icon is showing that we are discussing on deep neural network supports business. Okay, so let me start with this. Now see here, here if you go supplier performance prediction. Okay, so supplier performance prediction involves using data and predicting analytics to forecast how well a supplier will perform in the future, particularly in terms of quality, delivery and cost. Right, that is what I am telling you. There are different suppliers with different qualities. Now on the requirement how well they will perform. Now see here, quality, defect rate, compliance with specification, cost variance. These are some examples. Right, now let's take this implementing DNN, deep neural network, for supplier performance. Now here is the input data. Now data pre-processing, standard scalar, and with the help of training set. Right, training set, we generate one output, activation function. After that, this activation function features extraction using pre-trained model. Right, then machine learning model, and with the help of model evaluation and prediction visualization. So this is how we predict. This is the internal mechanism. You just remember this, memorize this image. We will see it practically how it works. Now first of all, let me show you this practically. Now here I have already created. Now again I am going to create a fresh IPyNUP file, interactive Python notebook. Here it is, IPyNUP file. You can see here IPyNB, interactive Python notebook. Okay, now start with this. Okay, for doing this, first we have downloaded the Excel sheet of the suppliers data. Fine. Now to work on this, what we need to do, we need to import first all the libraries. Since Python supports all libraries, that's why it is very useful. Now see here, pandas SPD, very well known library. NumPy, torch.nn, nn means neural network, and then torch.utils, data loader, data set, random split, and then sklearn, pre-processing, and then train, test, split, and then plot, plt. This is all we have already done for the last few sessions. Okay, now let's wait for 2 more seconds. Let it finish, then we will start. Okay, now all the libraries are pulled here. Now see here, load data set. Our main target is to load the data set. Right, now loading the data set. This is pandas pd.csv. Right, after that, look at this controls. Now let me explain you what is this first. If I go to X or Y, look at this, what we have done here. First make it as a df, and then now look at this. If you see 837,999, okay, see here what we have done. This 5 columns as independent value. X df dot ilock -1, that means here is -1 means remove the last column which is dependent performance score, and here you will see this -1 is without colon. That means it will take that last column. Look at this, 7901289 7901289. Okay, so it is divided into two variables. Normally also we use features in our last sessions. We have seen features. Here we have done it with different, with some pandas command. Okay, so here you will see x variable and y variable. X means independent variable, y means dependent variable. Okay, now what next? Look at this standardize feature. We are going to now standardize, normalizing the data. Scalar equal to standard scalar, then scalar fit to transform. That means converted data between -1 to 1, right? This is just to work fast. For example, if I put here, look at this, the data is converted between -1 to 1. Okay, after that, what next? Convert them into tensors. Since we know that this DNN and other machine language tools, they understand only tensor language. Tensor language is used everywhere, right? Anytime. Suppose if we are using on image data also, there also tensors will be used. You might have heard about the face recognition device which is mounted on every office in metro cities. You have to just stand in front of that, it will recognize your face and then it will say okay, thank you. So your face is detected and that face image is converted into tensor, and then that tensor is matched with the database tensors, and if it is matched more than 90%, that means it will consider that okay, the correct person is in front of us. Okay, in this way. Similarly with the thumb impression also, same technique. Okay, now here we are going to create the tensors. Okay, suppose if I put like this, x dot shape, right? So 5 is the column, right, and 5000s are the rows. Okay, now what we are going to do here, now see here, supplier dataset. We have created one dataset, this complete function, and in this supplier dataset we have passed the tensors, x tensor and y tensor, right? We have created this x tensor and y tensor. We have passed that data into the tensor. Okay, now suppose if I write here dataset dot shape, okay, no, this is not a proper command, dataset only. Okay, now if I show you this, okay, now train test bit again. Now this is our standard user formula. Train test split means 80% data taken for training. Here you can see 80%. Pointed means 80% data taken for training. Test size, that is remaining test size, length of dataset minus train size. Okay, that means remaining 20%. Remaining 20% for testing. Train dataset, test dataset, random split dataset, train size, test size. Okay, after that you will see train loader, data loaders, train dataset, batch 3. Batch size means 32, means it is a set of 32. For example, again the same example I am giving you. Suppose suppose 2 candidates are coming to me for the interview purpose. What I will do, I will prepare some criteria, and on the basis of that I will judge them. So these are called the batch size. Exactly on what basis I am going to judge them. Here also 32 means, we are creating the batch size. Then test loader, train loader is different, test loader is different, data loader, test data set, and then batch size is 32, set of 32. Okay, now what next? Let's check it out. Then define the model. Okay, so defining the model, Now supplier model, we have defined the model. Forward model, it passes the data in the supplier model. Okay, then you will see here just hold on a second. Okay, now let's check. Now model, supplier model, x dot shape 1. X dot shape 1 means the very first column that we are sending. Okay, now loss and optimizer. Loss and optimizer, whatever the loss is calculated or whatever the loss is given, so in that case we optimize that, we remove that loss, right? We adjust that loss. So criteria equal to NN dot neural network dot MSE loss, mean square error loss. Optimizer equal to torch dot optim. Here we have used the optimizer, right? So now what we are going to do here next, that is the training hour loop, right? So training hour loop means again the epochs, same process, right? So let's enter this. Now look at this epochs, we are taking 100 epochs. Okay, here we are taking 100 epochs. Now train losses empty array, test losses empty array. Okay, for epoch in range, and then we are using this optimizer 0 grade. You will get predicted performance score. Okay, then here the difference between the predicted and actual. Look at this, here the difference between the predicted and actual output. Okay, if loss is yes, then back propagation. You see here, if the loss is yes, then it will be again sent to the backward process, right? And this line is to improve the accuracy, right? So this is how we calculate this, and here everything is predefined. And now I am going to run this. Now see here, the epoch is running right now. So here the epochs is running, right? It takes a little time, we have to have the patience. It is running, still running. Just wait for a few seconds. Now it is done. So you can see here the train loss, it also decreases, and the test loss both decreases, right? That means the loss, overall loss is decreased. So that is why we run the epochs, right? Okay, now what next? Now we are going to plot this data. Okay, so plotting the data. Now from this point it looks very easy. The actual part is the above part. Okay, now see here, you can see train loss and test loss, both loss, and they both are decreasing, right? You can see here, this is the image. Now look at this, predict on test set and plot actual versus predicted. Now predict on test set, right? So what we are going to do here, we are going to plotting predicted and actual y value, right? Y actual and y predicted. So what will be the process here? Everything we have given, right, for xb yb, right? And after that I will hit the enter button. Now what next? Now see here, actual and predicted we have already received, right? If I suppose, if I, instead of doing this, if I put y underscore, look at this, y underscore now what I am going to do here, we are going to just plot the image. Now look at this, if you see, there is no much difference. You can see the orange color line is just following the blue color line. Orange color line is just following the blue color line. That's it. Okay, now if I show you, now finally what we have done, see, after seeing this image, what we understand that there is no much difference, actual versus predict supplier performance. That means whatever the performance of the supplier is actual, on the basis of that whatever we have derived as predicted, both are simple, right, equivalent. That means accuracy, you can see here. Now see here, example, new supplier feature input 5 value. Let me do one more thing for you. Just copy this here. Here it becomes. Now look at this. 085 means on time delivery, right? Delivery rate. 0.9 is the quality score. 0.75 is the cost efficiency. Then compliance score is 0.8 and then 0.7 is flexibility score. Now what I am going to do, scale and predict. Now see here, new data scaled, again the same thing, new data is given to them. Now new data is scaled here, look at this, say scale.transform. So what I am going to do here, put a narration, new data being scaled. With the help of this torch tensor, new data scaled, d type equal to torch.float 32, and then model.eval, and then with torch or no grade prediction, here prediction equal to model new tensor. Okay, now if I hit the enter button, now see here, supplier performance is 82%, right? Now suppose on time delivery rate is just take 15%. Now what will happen? Look at this, 78% will be the performance. Another thing, quality score is 99%. Let's take, then what will happen? Look at this, it increases. Similarly, if you see here, cost efficiency is very good. Okay, so on time delivery a little slow, Cost efficiency is also there. So in this way, what we are going to do here, I'm just changing this data just to show you flexibility score. For example, if I make it as 97, in that case it will increase from 0.88 to 90%. So these are the factors on the basis of which we calculate. Now let's have a quick recap again, right? And on the basis of this only the supplier performance is calculated. Now let's have a quick recap again. And the basic understanding is how DNN can help the NetSuite ERP or the business, and for that purpose we take some examples, we take some data from NetSuite and apply these concepts on the data, right? Now again, one more thing here, let's take a quick review. First of all, I have downloaded the CSV sheet on my local laptop from the NetSuite, right? We created some saved searches or the reports on the basis of which we could be able to download the report, right? After that, we pulled first all the libraries, and then we read the data set. Then we divided the data set into two parts. X means independent column which are already there, and Y means dependent variable. Okay, now here we have divided into this, and then standardized feature. With the help of this we scale the data or the normalize the data, right? Then X scalar dot fit to transform. So what it does, converted between -1 to 1. That means it convert the data between -1 to 1 to work fast, right? Okay, after that X value is here and Y value is here. Now convert it to tensor because the machine language understand only tensor language, right? So it understand only tensor. After that, you will see here we will create one supplier data set, right? Supplier data set. In this supplier data set we have just entered the tensors. We just pass the tensors here, right? Now train test split function is the another function that we have been using since our series started 1 month back or 2 months back. So here you will see the supplier model and all these things, right? So you have to send the data to train loader, right? Train loader and test loader means with the help of data loader we supply the data. Test data set. In first it is a train data set. Now see here, training loader created. Okay, and with a batch size of 32. Now see here, supplier model. Here supplier model is created. Now again the same thing. First of all the input is taken, then since it's a sequential data, right? So linear input size, that is 64 neurals are created. Then you will see here ReLU function, it is an activation function. Again the linear 32 neurals are created, and finally at the end only one output is created. So this is how it works. Now model equal to sublimizer X. Supplier model, right? So model equal to supplier model equal to X. Now loss and optimizer, you will see here criteria equal to NN MSC loss. Now optimizer torch. With the help of this function we will now train our loop, right? Train losses and test losses. And with the help of this epochs, we run this epochs, and then here you will see this is a complete internal mechanism. Here we have to write it as it is, and after that you will see the loss is reduced. So our main target is to reduce the loss. After that we plot the data. Now we plotted the data. Right now we have not given the original data or the test data, right? So you can see here the losses are decreased. After that you have to predict the test set. Look at this, whatever the test set and actual set we have predicted. Now it is showing almost same one over the other, overlapping the other. Then what we have done, we have predicted with test data replaced with real values. Now you can see scales and predict with the help of this, all these things. You will see the predicted supplier performance is 90%. 90% means much better, far better. So if the supplier gives us like something like this type of data, if the supplier gives us, in that case we can predict the performance. Clear? So guys, this is another most important topic to predict the suppliers performance, right? Because in our daily life we can analyze 1% or 2%, but analyzing such a big data, suppose one company is having 1000 suppliers, so analyzing the big huge amount of data, we use this deep neural network concepts, right? So guys, my recommendation to you to go through this video twice, thrice, and then it will be easy for you to understand, right? And if you have any doubt, you can directly put down into the comment box. I will be there to help you. And then after that, practice this. And those who have not subscribed my channel, please subscribe the channel. So let's meet on Monday. Thank you guys. Thanks for attending the bootcamp session. Thank you.